Okay, this video talks about complex numbers, part one. Um, so we're really just focusing on this equation right here. In the next video, we'll talk about this equation. So this just kind of gives you an introduction to complex numbers, which are a combination of real numbers and imaginary numbers. So real numbers you can read here are pretty much any number you can think of, counting numbers, 1, 2, 3. We could include fractions, decimals, square roots, cube roots, even pi is a real number. Imaginary numbers happen when there's a negative under the radical. So whenever we see a negative under the radical, like all these problems, we know we're dealing with imaginary numbers. And so the example I gave to the class is, what if I gave you, and I'll put it up here, what if I gave you the square root of -4? Well, that means something times something is going to give us -4. And so you may think, okay, what about -2? Well, -2 times -2 is +4. And +2 times +2 is +4. And remember, they have to be the same number with the same signs. We can't do +2 times -2. That doesn't work. And the reason you can't think of anything here that works is because real numbers don't work. We need imaginary numbers to answer this. And so that's why we use imaginary numbers. So the I is the unit and the variable we use to represent an imaginary number. I is equal to the square root of -1. That's what we're going to focus on today. So let's just look at some examples so you can understand why we need this value I. So for number 1, we have the square root of -36. If we have the square root of +36, this would be a really easy problem. It would just be 6. But we have a negative, so +6 won't work, -6 won't work. We know we're dealing with imaginary numbers. So what we want to do is set it up like this. It's really equal to the square root of -1 times the square root of +36. And hopefully this makes sense, because if we were to multiply these radicals together, we get the square root of -36. And so the reason we pull out this -1, the square root of -1, is because we know it's equal to I. So we can cross this out and change it to I. And then the square root of +36, we can do that. We know that's just 6, since 6 times 6 gets us 36. And so we have I times 6, and generally we see the number in front. So our answer would be 6I. Okay, and so for number 2, we're going to start off in a similar way. We see the negative under the radical, so we know we're working with imaginary numbers. So I'm going to pull out the square root of -1, multiply it by the square root of +28. Again, we can do this because if you multiply them together, we get the square root of -28. And the square root of -1, well, we know that's just equal to I. And then the square root of 28, we don't know that one by heart, but we can simplify this by using a factor tree. So we could use 2 and 14, 4 and 7, doesn't matter. I'll do 4 and 7. And we have 2 and 2. So remember, we only care about the numbers at the ends of the branches. So you may want to cross out that 4 so you don't get confused and accidentally use it. But we're going to circle our pairs and underline our singles. Couples go out, singles stay in. So the 2 is going to go on the outside, and the 7 is going to stay on the inside. And then finally, I have to bring down this I that we're multiplying in. And it's not wrong to leave it like this, but usually we see the whole number first. So I'm going to actually write it like this, 2I square root of 7. I just flip the I and the 2. We will usually see it written like this. Okay, for number 3, we have the square root of negative 50. I'm going to start the same way. I'm going to pull out that negative 1, multiply by the square root of positive 50. The square root of negative 1, that's just equal to I. The square root of 50, it's not a perfect square, so we'll have to do a factor tree to simplify this. We could do 25 and 2, and 5 and 5. So we have a pair of 5s and a single 2. Couples go out, singles stay in, and then I'll have to bring down my I to get multiplied into all of this. And again, we generally see this written with the 5 first, so 5I, square root of 2. Okay, for number 4, we have the square root of negative 88. We're going to pull out the square root of negative 1 and multiply by the square root of positive 88. Square root of negative 1, that's just equal to I. Square root of 88, we'll have to do a factor tree. So we could use 8 and 11. And we could do 4 and 2, 2 and 2. Remember, we only care about the numbers at the end, so we can cross out the 8 and the 4. We'll circle our pairs, underline our singles. Remember, couples go out, singles stay in. In this case, we have 2 couples, 2 and 11, so we'll multiply them together, 22, and then put them under here. And then, of course, I want to bring down my I. And we'll just flip those. So it's 2I square root of 22. Okay. And for number 5, you can see we have a coefficient out in front. We have this 2. So we know this is really 2 times the square root of negative 16. It's not that much more complicated. We're just multiplying a 2 in. So I can separate the square root of negative 16 just like I did for the first 4 problems. I know this is equal to the square root of negative 1 times the square root of positive 16. I'll bring down my 2 out in front. That's getting multiplied into all of this. And I know the square root of negative 1 is equal to I. The square root of 16, you could do a factor tree on it, but that's a perfect square. That's one we should have memorized. So that's equal to 4. I'll bring down my 2. So now we have 2 times I times 4. Well, we can multiply the whole numbers and then attach the I. One mistake I saw a lot is that people were putting this as the square root of 4. And that's not right. It's the square root of 16, and it's equal to, the whole number 4, not the square root of 4. Okay, for number 6, we have a coefficient out in front again, so we're going to treat this the same way. I'll keep the coefficient out in front and break this into the square root of negative 1 times the square root of positive 72. I can cross out the square root of negative 1, that's equal to I. Then I'm going to have to break down the square root of 72. So there's lots of things you could use. I'll go ahead and use 36 and 2. And then I can break that into 6 and 6. And remember, once I hit a pair, I can actually stop there and circle it. I'll underline my single. We don't care about the 36 because it's not at the ends of our branches. So couples go out, singles stay in, and then I have to bring down my I. I also have to bring down this 3. Okay, and so we'll multiply the whole numbers, 3 times 6, attach our I, and then attach our square root of 2. So 18i square root of 2. Okay, for number 7, we have a negative coefficient, but that's okay. Works the same way. So my coefficient will go out in front, and I'll have to separate this negative radical into the square root of -1 times the square root of +9. Again, we always want to do this because we're trying to leave this in terms of I. We're trying to pull out that I. And then the square root of 9, that's a perfect square. We just happen to know that is 3. This is really -6 times I times +3. -6 times 3, that's -18. And then I can just attach my I. And then we have this last one, the square root of -3. There's no coefficient, so I can just go ahead and separate this into the square root of -1 times the square root of +3. I know this piece is equal to I. And the square root of 3, we can try to do a factor tree on it, but we can't actually simplify it. It's just a very small number. There's no pairs or anything. So we'll just go ahead and attach it right here. Okay, so before we move on to the back, I just put this down here so y'all realize what complex numbers really look like. We always have a real part that goes first. In this case, it's the 9. And then we have an imaginary part that we put last. That's just how we write it. That's just how mathematicians do it. So I wanted you to go ahead and circle the real numbers and put a square around the imaginary ones, just to make sure you can recognize the difference between the two. So this one, -13, is real. I is imaginary. In this case, the whole thing is imaginary. There is no real number. You could think of it as 0 maybe out in front. In this case, 3 is real. -4i is imaginary. Okay, so on to the back. We're just adding and subtracting. And this is pretty easy. We actually have already done this topic like the first month of school. But instead of i's, we saw x's. But it really works the exact same way. We're just going to have to distribute where it's necessary and then combine like terms. So here we have parentheses, but there's a plus sign in the middle. So that means we're really distributing these positive ones. It doesn't change anything. So we don't even really have to have parentheses for problems like 1 and 2. We're just going to go ahead and combine like terms. So the like terms would be the ones without the i's, and then the ones with the i's. So 9 plus 4 is 13. 2i minus 9i is -7i. Notice I put my real number first and my imaginary number last, and that would be our answer. Starting kind of easy. Same deal with number 2. We'll combine our like terms. 9 plus 13 gives me 22. -6i plus 8i gives me +2i. Okay, for number 3, we have to distribute. We have to distribute this 2 out in front to everything in the parentheses. And then this -3, we're going to have to multiply by the 7i. Okay, so 2 times 4 gives me 8. 2 times 3i gives me a +6i. And then -3 times 7i gives me -21i. We don't want to leave it like this. We can still combine some like terms. I'll bring down my 8, and then 6i minus 21i is -15i. Over here we have a minus sign now between parentheses. It's kind of like a negative 1 out in front that we have to distribute everything behind it in the parentheses. The first expression doesn't actually change at all, so I can go ahead and bring that right down, my 14 plus 3i. But now I'm doing negative 1 times 8. That's negative 8. And negative 1 times 2i. That's negative 2i. And then I can go ahead and combine like terms again. So 14 minus 8 gives us 6. 3i minus 2i gives us 1i. Or we could just write I. Same thing. Okay, for this one, again, we're going to have to distribute this 2 to everything in the parentheses. So 2 times 15 gives us 30. 2 times I gives us positive 2i. I'll go ahead and bring down my minus 12i. And then again, we're just going to have to combine these like terms. So I'll bring down my 30. 2i minus 12i gives us a negative 10i. And that's our answer. And then for this last one, we're going to have to distribute this negative 2 to everything in the parentheses behind it. My first expression doesn't change, so I can bring down my 3 minus 14i. But then I have to do negative 2 times 8. It's negative 16. And negative 2 times negative 6i is positive 12i. And from here we can combine like terms. 3 minus 16 is negative 13. Negative 14i plus 12i is negative 2i.